I'd like to give a small talk about CalDAV, which is a calendaring protocol, actually about CalDAV, CardDAV, and WebDAV. And it's mostly intended for open source developers because I want to motivate them to implement those protocols. So actually I will give a short overview of the protocol itself. I'm talking a bit about the implementation which exists today. I want to say a bit about how to write a CalDAV connector. So if you're a developer and want to provide a CalDAV client, I give some hints on how to work on that. And well, related to that, how I think you can help with getting better CalDAV support in open source clients. So as I said, CalDAV is a simple HTTP-based calendaring protocol. It's a standard since last year. It basically describes how an open or any groupware client, like for example Thunderbird or Evolution, can talk to a server system, like for example eGroupware or OpenGroupware or Sarafa, of course. And well, the important thing to keep in mind is that CalDAV is just a transport protocol, so it doesn't describe how the actual data is formatted. For the actual data, the iCalendar and vCard formats are used, which are in a standard since, I think, more than 10 years. And the important thing is that all the open source clients which exist today, like Evolution, Mozilla Sunbird, and Contact, are all internally based on iCalendar and vCard. So it's a very natural fit. And this is why I don't like articles like that. You can read that for Contact or for Evolution. So there are announcements like Contact or Evolution support Microsoft Exchange. And well, it's very annoying because they do not yet support open standards, but they put work into supporting Exchange. I can't understand that, especially because the clients itself are based on the data formats also used by CalDAV. So it would be very easy. A bit about the protocol. Actually, the whole stack is pretty complex, but you usually don't need that because CalDAV also targets web interfaces. So it has a lot of operations so that web interfaces can directly talk to a CalDAV client. That's not something I'm talking about today. I'm mostly interested on what needs to be implemented in a native client, like a KDE client or a Genome client. They need much less operations. In fact, we have a small subset of that defined in the so-called groupware standard. It's not really a standard, it's more like a document which contains the interoperability issues. I'll show that later. Well, to the parts, iCalendar is very common. Most developers probably know how that works because, as I said, it's used in the open source clients anyways. It's very simple text-based format which contains the necessary information. Nothing particularly impressive. The same goes for vCard, which is almost the same format except for contact data like telephone numbers and email addresses and stuff like that. You can store birthdays in vCard. Well, and the most important protocol for CalDAV is HTTP because almost everything needed to write an a client-server system which does calendaring is already contained in HTTP. It provides operations to retrieve items, to store items, to delete items. Well, and it's actually, there's a new buzzword for that, which is REST, which just means that HTTP is applied as it was originally intended, which is using those operations instead of using just POST and some CGI scripts which do other stuff. So this is how the HTTP looks like. This is for retrieving an item. You just use a GET method to retrieve a URL which contains an event in this case. The if no match is actually an optimization. The number behind that, it can be anything. It's just a marker which says whether the item changed on the server. So if the client retrieves such a calendar event from the server and stores that into its own cache, it can put that version into the request, and the server will only return the content if it actually changed. So it's much faster. In this case, it changed and it actually embeds, well, actually it's a bad example, it didn't change, but it actually embeds an iCalendar file and gives a new e-tag. In this case, it's the same. Changing an item is becoming relies more on the if match header because the put operation is used for both, for changing an item and for creating an item. And in addition, a put operation, a write operation, must detect changes by other users. For example, if another user moved an appointment in his client, another user must be able to detect that so that he doesn't overwrite the changes of that other user. And this is what the e-tag is used for again. So this basically means only writes this content if it didn't change. So if it changed in the meantime, the server will issue a special HTTP status code, which is 419 conflict. And the user can then decide whether the client should reissue the same request without the if match, or whether it somehow retrieves the updated information and merges them, or, well, whatever choices the client gives the user. As I said, creating the item is basically the same thing, but to ensure that the event does not yet exist at that URL, you put that if non-match star into the header. This means that this request will fail if the meeting ICS file already exists. In this case, the client needs to issue a new file name for that event and retry the request. So most clients actually use unique IDs for that, so it's very rare error. Well, and final delete, it's also very simple. If you want, you can also add an e-tag condition so that the delete only succeeds if no other user modified the event in the meantime. Yeah, you can also remove that and the delete will always succeed. Well, what we have seen before is just regular HTTP. It's in the standard HTTP specification and available for a long, long time. And the same is true for WebDAV. It's quite available for a long time now. And the most important thing WebDAV adds to HTTP is hierarchies. So HTTP itself, a URL, a uniform resource locator in the HTTP request, is already kind of forms kind of a hierarchy. The components in the URL can be split by slashes, and but the important thing is that there is no HTTP operation to discover which children such a collection has. For example, if I want to know that the developers folder contains a calendar and tasks sub-items, there is no HTTP operation to find that out. And this is what the prop find is for. It's the addition by WebDAV. Another addition is that WebDAV has a concept of metadata. They're called properties in WebDAV. So by using the prop find, you can also discover stuff like when got the file modified, what is the e-tag, and other stuff. It's also the basis for WebDAV extensions. It has a few other things like, for example, log, which allows you to log a collection for modification. But that's not really necessary because, as we've seen before, HTTP already supports optimistic logging. So you can just attempt to write and it will only fail if it actually changed. So it's usually much better for the user instead of logging the whole collection. So that's how what it looks like. It's a prop find operation which goes to a calendar in this case, and the prop find instructions are contained in the body. As a get e-tag, this says that we want to retrieve the e-tag of all items contained in that calendar. And it always returns such a multi-status response, which is basically an XML representation of multiple HTTP responses. So in this case, the e-tag is returned and it always embeds the thing in such a response element which contains the URL to the item which is below that collection. In this case, calendar and some item, it's just a unique ID. The user usually doesn't see that. What else? For CalDAV, just below CalDAV, there's also another extension to WebDAV, which is WebDAV ACL. That's access control. So most important for CalDAV are so-called principals resources. Principal resources are just a standard for representing an account in a calendaring system. So you actually get an URL, for example, principals users Helga, which represents that account. And this URL can be used to retrieve some information about that user. Usually those principal resources are not stored in some file or something like that, but they are usually backed by some directory service, for example, LDAP. So, for example, the Apple implementation uses Open Directory to store the actual principal information. But it's not just individual users, it's also groups and resources like rooms, which can be represented by principal resources. The most common use in CalDAV is that the so-called calendar homeset property. There's the same thing for address books, which is called address book homeset. And the way it works is that you do a prop find on the principal URL, and you get back those two properties, and they contain the URL which points to the server which provides the calendaring and address book services. This is pretty nice because it allows you to scale very well. So you can distribute users to different servers. You can use different servers for address books and calendars and stuff like that. Well, it's about ACL. It also does a lot of permission thing, but that's not really relevant in calendaring that much. It's an extension. I really want to have the open source developers to implement the basics first. So CalDAV, as I said, requires most of those protocols. If you want to do a full CalDAV implementation, you would actually have to implement all those protocols or all those standards. In practice, almost no server does that. Most servers just implement the subset which is actually required to drive the Apple iCal client, because this is the most known CalDAV client and more or less the standard to test the CalDAV features. But I come to clients later as well. CalDAV, is just one additional HTTP method which is introduced in ACL actually, but it's also used in CalDAV, which is called report. It's pretty similar to the prop find, but is a way to extend the protocol. The report request is in the body, and well, because native clients which run on the desktop computer usually keep a cache for offline information and stuff like that, we do not really need the report, because all the queries like give me a week of appointments or find a contact with name hello world are done on the client, not on the server. This is something which is important for web clients. For example, a web client could ask the server to return just a week of events. But for native clients, it's usually a useless feature because they have their own cache and do the queries in the cache. There's one report which is very useful, and that's a so-called multi-get report. When you synchronize a server the first time, and for example, it contains 1,000 events, what happens is that the client issues a prop find, it discovers the 1,000 event URLs, and then goes on to fetch 1,000 or does 1,000 requests, GET requests, to retrieve the item. Actually, that's not that bad as it sounds, because HTTP 1.1 also supports pipelining and persistent connections. So issuing 1,000 requests isn't as slow as one might think, but still, especially in database-based servers, a multi-get can give performance advantages. It basically says that in the multi-get report, you can specify a set of URLs, and you get, for example, 50 events in one batch by just issuing one HTTP call. So it can be a major performance improvement. But for example, I'm also testing against Apache, which doesn't implement report. It's very fast with GET as well, because it just pulls out the files from the file system and puts it on the socket. It's very, very fast. Could we do questions later, please? Or?
You seem to be wondering about the servers. You seem to be dismissing the server with no servers do everything. As a server developer, it would be nice to know where to look.
Exactly, and I come back to that later. It's actually the thing we want to document in groupdev, because we think that groupdev is a subset of all those specifications which are needed to implement a client system. Everything else can be done on demand. For example, you can issue a report. If it isn't implemented, you get back an error code, but I show that. Let's wait a minute. That's something I actually wrote just below. So while you can use a CalDAV report to retrieve a bulk, multiple events in one step, if the server says he doesn't support that, you can still fall back to GET. It's not a lot of work for the client developer to do that, because it's just an optimization. So, and the important thing is that this GET is, again, plain HTTP, so it works with servers which do not implement full CalDAV or that particular report. As I mentioned, there are a lot of different reports. You can extract just subsets of the iCalendar file and stuff like that, which are interesting if you want to write a web interface which directly interacts, using the browser interacts with the web server, but I've never seen that, and I think it's pretty useless, actually. CalDAV is basically the same like CalDAV, just that it's for contacts. The contacts are stored in read cards. There's also such a multi-get report, but in any other way, it's the same thing like CalDAV just for contacts. So it's currently still in development. Well, actually, Cyrus Tabu is the guy who has written the draft, but I expect that this will be standardized during 2009, probably in July or something like that. So here we are coming to groupdev. With groupdev, we try to formulate the absolute minimum of operations which are necessary to maintain a proper client cache, so that a native client can be developed which interacts with such a groupdev server. The reason is that, well, as I said, CalDAV and even WebDAV itself is pretty complex. If you want to implement it, very few people actually implement the full specification. But groupdev is super simple. It's not even requires you to implement all of WebDAV. If you do, it's great, because you can use regular WebDAV clients, but a real groupdev client can operate with, interoperate with much simpler servers. So it's just one prop find query which we specified in part of that groupdev document. I'm showing that later on. And you can, yeah, as per a groupdev specification, you are not allowed to issue different prop finds. This way, it's 100% compatible to WebDAV and CalDAV. So every groupdev client is automatically a full WebDAV or calendaring WebDAV client and can talk to any CalDAV server, because any CalDAV server by specification implements those things. Otherwise, it's just same thing like get, put, delete, everything plain HTTP. Content types are vcalc and iCalendar. Folder discovery is used using the prop find. So in the results set, you get responses for the folders, we actually need to tag calendar folders with a special type so that the client knows that this folder is a calendar server. Well, and the cool thing, or in my opinion, the coolest thing is that you do not need a groupware server at all. You can use just Apache, the Apache WebDev support. You just need to enable the WebDev module of Apache, and you can use to store that in groupware environments. And it's not fishy or something, it's properly protected using the e-tags, so concurrent edits and all that work. Disadvantage, okay.
Wait, sorry.
Now it works. Okay, great. So, the only real disadvantage is that, of course, you do not have a web interface or something like that. So it actually only works with real clients. So it isn't too difficult to write a small script or something which watches the Apache directories for changes and just generates appropriate HTML files for that. You can do that using file system callbacks and just generate a web interface, a static one, which is very scalable. Yes?
So does it mean that if I put all that on my Apache server, I can basically attach a CalDAV client to it and use that as a CalDAV server?
No, not a CalDAV client, a groupdev client. You could use any groupdev client. The CalDAV client, or most on the market, like for example iCal, really do use those report operation, for example, and have no callback. A groupdev client could also attempt to use a report, but would fall back to prop find and the regular operations. But I also talk about the implementations. I come back to that later. Maybe check the time as well. Okay. In my opinion, it's very cool because everyone has an Apache WebDev. It's included in the latest releases, and it really works great. It's very fast, even for larger collections. It doesn't scale to 100,000 events in one folder, but for regular use cases, it's pretty nice, actually. So groupdev, as I said, is for offline clients only. We do not provide operations which are necessary for web interfaces, like give me just 1 week of events. So we actually assume that the local client keeps a cache of the item it retrieved before, because otherwise it would always need to retrieve all events. It wouldn't work. But groupware clients, local clients need to keep a cache locally anyway because you want to have offline capabilities. So it's not really an additional requirement. As I said, it's very simple, especially for the server vendors as well, because they only need to implement that single prop find and the get and put operation, so it's really easy. And it also has a few hacks. We documented a few hacks which can be used to better support database-based servers, like for example eGroupware or OpenGroupware. It has to do with the URL constructions, but I do not really have the time to go into detail. On top of CalDAV, the committee added another specification, which is CalDAV scheduling. That's basically the same like IMIP, which is used to exchange invitations. For example, if I'm a user and I want to invite another user to a meeting, my mail client like Evolution and Contact almost anyone supports that. They send an iCalendar message embedded in a regular MIME mail to the other user, and he can then accept the meeting, and all the interaction in that is documented in iTip and IMIP. Standard protocols which are widely deployed and standardized since a lot of years as well. And CalDAV scheduling is almost the same thing, just over HTTP. Well, if you are a client developer and you want to start adding groupware support or CalDAV support to an open source client, please do not look into that. Yeah, it's quite complicated and it doesn't really buy you that much because the IMIP also works perfectly fine with calendars stored in CalDAV. So you can just exchange invitations via email, which is completely standard. Even Outlook and Lotus Notes support that quite well. Not perfectly, but quite well. So you can actually interoperate with those people and schedule meetings. So, but we'll see. Scalability, I talked about that a bit before. Of course, especially a groupware system with a local cache is really scalable because it has that cache, it does all the operations in that cache and doesn't need to call the server to perform operations like, well, sorting events or search for context. So the actual processing work for searches is put on the client. So it's quite fast. Due to the architecture, because it's based on HTTP, it's really super scalable. You have all the features of HTTP which are used to make websites scale. And actually the events which are transferred by CalDAV, the files are much smaller than an HTML page. So you can actually use caches like Squid if you have a really large system to reduce the load on the application servers. And use e-tags with that, because if the cache has the e-tag, he knows whether the cache needs to retrieve the file from the backend server. So there are a lot of features which make that very scalable. Well, as I said before, HTTP also supports persistent connections, so issuing a lot of requests isn't that bad as it sounds. But most importantly, HTTP itself also supports compression. So it's not so important for the events if they are transported because they are quite small, but the XML of the prop find can become quite big. I put some numbers roughly. So 1,000 items produce an XML which is about 200K, which is quite a lot. But because the XML is so verbose, it also compresses very well. So if you enable gzip compression in the client, it just comes out as 12K, which is quite okay. And well, even for 10,000 events, which is quite a lot for a single folder, it's just, well, it's not just, it's more, it's 130K, which is significant, but acceptable in my opinion. But most extensions which exist to that protocol are trying to improve the situation with the XML overhead. And especially Apple is doing a lot of work on that. There's a Darwin Epic calendar server, which is completely open source. And it's written in Python and more or less acts as a testbed for features. The developer of the Apple server is Cyrus Dabu, which also worked on the CalDAV specification and wrote the CalDAV specification. And before he puts those into specifications, he usually implements that in the Apple server. And for reducing the prop find overhead, there are actually two things. The one thing, which is already in production use, is C-tags. C-tags are like E-tags. An E-tag says whether an event has changed by some other users or by some other means. C-tag is roughly the same, except that it covers a whole collection, a whole folder. So if anything in the folder changes, the C-tag changes. So the client can check for the C-tag, and only if it changed, it does a full prop find. The nice thing is, again, if you write a calendaring client, you can check for the C-tag, and if it doesn't work, you can still do the regular prop find. So it's very easy to fall back to basic functionality if that's necessary. And very new, it just got into the Apple server trunk a few months ago, is Java-based PubSub. That's a way to let the server inform you about changes. So it's actually an information triggered, a notification triggered by the server if something changed in the server. So the client only needs to do the prop find if something actually changed. And that's all. Everything standards-based, it's Java. And if it isn't available, the client can just fall back to CTEX and to regular prop find in the second row. It's really not bloating the code, actually. Well, and all the extensions, you can actually look at that. It's written in Python. It's okay to read and available from Apple. There are a set of known issues, but most issues, if you talk about CalDAV and CalDAV, are not related to the protocols. It's usually related to the data format, which is iCalendar or vCard, because especially iCalendar can be quite complex. For example, if you have recurring appointments and stuff like that, in iCalendar you can build pretty complex recurrence rules which are not supported by any client. But in the case of open source calendaring clients, it's no issue if you want to add CalDAV support, because those clients are based on iCalendar and vCard anyway. So the developers of Mozilla, of Evolution, and of Contact already did all the hard work of doing the iCalendar implementation, for example. The best iCalendar implementation has Contact, I would say. There are a few other issues, but you are not really hurt by that in practice. We can talk about that if you run into that. It shouldn't be a hurdle. Okay, I want to tell a bit about the implementations. That's about the situation mid of last year. There were those groupware effort, which I started personally in about end of 2004. There are about a few smaller vendors which support that, like Open Groupware, Citadel, and eGroupware. There was a work on the CalDAV standard, which is mostly done by, or was done by Oracle, by Apple, and also BetaWork, which is an educational calendaring system. It's written by an American university. But really, the huge amount of groupware system, open source groupware system, just invented an own protocol for their needs. So for example, if you have Contact, you have something like, I think 10 or 15 different plugins which can connect to the groupware servers. And well, right now, I think in Fresh Meat, there are over 400 different groupware systems listed. So it can't be the solution. But surprisingly, last year, the CalDAV really got adopted by a huge amount of vendors. That's mostly because everyone, for some reason, wanted to support the Apple iCal client. And the Apple iCal client only used the CalDAV protocol, which they probably put into an RFC. And so it's the first time, and as far as I know, that so many calendaring server vendors agreed on a single specification. So all of them either support full or partial CalDAV necessary to derive the iCal client, or groupdev. Well, it's really a lot. For example, eGroupware also implemented groupdev, but there are really a lot of projects which are doing that, and I expect that this will be the standard, like IMAP, for example, is for email. Even Google and Yahoo support CalDAV for calendar access last year. You can access a Google Calendar using CalDAV. So, because there are so many implementations, I thought I should suggest some. It's mostly, all of them are pretty good, but it's usually the developers have some affinity with the programming language. There's a dev iCal, which is written in PHP. I think it's actually a standard package in Debian as well. There's a Darwin calendar server, that's the Apple one, which is written in Python. There's Scalable OGO, which is written in Objective-C. BetaWork is that educational server, which is written in Java. There are a lot of alternatives to that. You can just browse FreshMet and find probably about 10 Java servers which are doing that. Yeah.
What about Apache plus WebDev?
Sorry? Apache?
I didn't misunderstood you. You mentioned Apache plus WebDev would be okay.
As a groupware server, a group dev server. For example, the Apple iCal client is not a group dev client because it uses the extended CalDAV methods. So to connect Apple iCal, you actually need a lot of CalDAV operations. But, well, I come to the client implementations later on, but it's for clients which are advertised as CalDAV clients, you usually can't use Apache WebDev. Yeah, but I come back to that later. And I would like to have that changed. Actually, if there are developers from the client project, that's basically my, well, what I would like to see is that they can probably fall back to group dev so that Apache is supported. Well, if someone knows the Perl or Ruby ones, tell me, write me an email. Well, as I said, I would suggest one of those servers. Well, my personal favorite, as I said, is Apache WebDev, and I've put a log of such a Apache transaction, which shows that how the fallbacks work. For example, the client in this case first tried to perform a report to fetch multiple events in one batch. And it gets a 405 return code, which says that that method is not implemented. And the client forwards back to just retrieving the individual events. And as you can see on the timestamps, it's pretty fast. Yeah? Even if the next batch attempt starts, it's really fast. It's like, I don't know, 2 or 5 milliseconds to retrieve an item from the server. And actually, well, I come back to that later, evolution, and there's an implementation for Outlook, but I would really like to see that in all open source clients. To the implementation, client implementations. First, there's Contact. We actually implemented a group dev in Contact together with some KDE people in end of 2004. We actually also specified that group dev during that session. It took about 2 days or weekend. Well, the problem is that KDE just rewrote all their infrastructure, so they wrote a new client library, which is called Akonadi, and it will be used in some later Contact version. The Contact still doesn't use that, and it doesn't provide any support for WebDev yet, so it's quite crappy. But we really hope that we will be able to change that. Probably if Contact is ported to Akonadi, we will have a development session with the Akonadi developers to add WebDev, GroupDev, and CalDAV support to Contact. I hope that we be able to do that until end of the year. The second one is evolution, of course. We also provided a GroupDev backend or GroupDev plugin for evolution. It was a Noodle project. It was sponsored by Junta de Andalusia in Spain. Unfortunately, it didn't really pick up at this time, so the connector just became unused, unsupported, unmaintained, so it can't be really used today. It's still in the CVS repository, but it's not really useful. But evolution actually has reasonable WebDev support. For one, you can configure CalDAV calendars, so you can use CalDAV and together with a real CalDAV server, but it doesn't provide GroupDev fallbacks. So Apache, for example, doesn't work as a backend for evolution. But evolution actually supports plain WebDev address books. So you can store a set of contacts in vcard format on an Apache WebDev server, and evolution can probably display them, edit them, and it works very, very well. So it's quite good. So I showed a bit collection browsing. Okay. This is a dialog of evolution for adding a WebDev address book. the thing which I do not like about that one is that you need to specify the URL to the actual address book collection. What I would like to see is that you just enter some URL and then would be able to browse through the server like in a file browser, because that's what WebDAV is all about. It supports hierarchies and you can browse through them using the appropriate prop find requests. So actually, if there's an evolution developer, please add a browsing module which allows you to select the address books on the server you want to subscribe. That would be much nicer. But even this address book is pretty nice. I just discovered that about 2 months ago, and it's really working very, very well. And as I said, it supports CalDAV. Well, it's a panel for adding CalDAV. I basically have the same complaint. You can browse the server for calendars. Well, but otherwise it works quite okay. So it's quite usable. But as I said, you need a real CalDAV server. And finally, Mozilla, the Mozilla clients, which are Sunbird and the Lightning module for Thunderbird. They are actually very good because first, a few of the Mozilla Sunbird developers actually work on CalDAV implementations. So it's unlike an Evolution or Contact, the core developers are actually into CalDAV and support that. So there's a lot of work on getting that working well. And in addition, there's a scalable OGO project, which is just another groupware server. And the scalable OGO project provides plugins for Mozilla, so it's just regular Mozilla extensions. And those extensions are not specific to scalable OGO. They are real GroupDAV clients and real calendaring service extensions. So it's quite good. And it's also very easy to hack. In the address book, for example, it also misses the collection browsing again. So you can't actually browse a server for address books or calendars. What other clients are there? First, there's a Funambole GroupDAV plugin. Funambole is a synchronization server which can synchronize WebDAV servers with mobile devices. So it's a Java application server, and there's a plugin for that, which is a GroupDAV plugin, which can basically synchronize a GroupDAV backend with any mobile device supported by Funambole. Personally, I haven't tried it, but I'm told that it works. There are other clients. Mulberry, for example, I don't like the user interface, but it's actually a pretty powerful CalDAV and IMAP client. There's Chandler, which is by the Open Source Applications Foundation, which also is based on WebDAV. There's, of course, Apple iCal. There's another one which is called EM Client and Outlook. Actually, there's even an open source project called Open Connector, which implements CalDAV protocol, but it's not very fast. So if you're a developer which is into Windows development, they need a lot of help, really. So my section about actually writing such a connector. As I said, it's not that, or shouldn't be that hard, because all the open source clients already implement the hard stuff, which is parsing and processing iCalendar and vCards. This is all done. All of the clients can do that. So what we need to add is basically a simple cache, which keeps items retrieved by the server together with the E tag and the URL. So it's pretty easy. And well, as I said, if you want to start such a connector, please just do the GroupDAV part working first, because you shouldn't really look into CalDAV extensions until the GroupDAV stuff works. It's very simple, and if that works, you can start adding CalDAV features with appropriate fallbacks to improve performance or provide additional features. But even if you just have GroupDAV, it's quite good already. It can be used in a lot of sharing scenarios. There are also quite a few libraries for doing CalDAV. For example, CalDAV for Java. It's a Java library to do CalDAV. CalDAV client library for Python. Open groupware has a library for CalDAV stuff. VObject is also a Python library. The Mulberry client also has a lot of CalDAV functionality packaged in various languages as well. So But still, I would say you don't need to use that because the XML you need to pass is just the response from the prop find query. It's just one XML format you need to pass, and it would be completely overblown to use a separate client library for that. It doesn't make any sense. So you should just use your favorite HTTP library to retrieve the items from the server, write one XML parser which parses that prop find, and that's it. Debugging tools. Well, if you're developing something, it's nice to have some stuff which you can use to actually try the thing, and I check where I can show you two. One is CURL. Probably many people of you know that client. It's just a command line client to retrieve HTTP servers using GET or any other option. Need to check. It's a bit. Does it work? Yeah, it's a bit small, the screen, but actually I've written myself a small shell script, and the essential stuff is basically the bottom. The stuff at the top is just for collecting the password and stuff like that, and the bottom actually issues a prop find, and the properties which are requested are in that prop find XML file. This actually contains the standardized prop find of groupdev, and it looks like that. So it's just the core set of properties which are necessary to implement the client. It actually contains some CalDAV and CalDAV properties. So if the server actually supports those, CalDAV protocol, the full or more of the CalDAV protocol, and can actually respond with data. A plain groupdev server would just not return anything. And for example, we can try that against some server. Actually, how did it come up? Anyways. That's the iPhone. Let me check. Misprinted. Yeah. So it's very convenient to see what the server actually responds with. So that's actually the Google Calendar, which is requested using groupdev. As you can see, it probably responds to that with an with a prop find response. That's the one you need to be able to pass. For example, the root URL, the Google Mail thing, is a root collection, and it contains additional stuff below. If there are any features it doesn't know, it puts them in such a 404 section. For example, this collection doesn't have a display name or a specific content type. So it's quite nice. So that's a CURL. It's quite easy to use to check what the server returns and what you need to pass. It's quite convenient. The other tool is CalDAV. CalDAV is a command line client for web dev. Let's see what I have. Okay, let's try the BetaWorks server, for example. So it's an interactive client. I can log in. And I can just go like through a file system. I can explore the server, and it's basically the functionality I would like to have in groupware clients as well. For example, here's the calendar of the user, and there are the ICS files. I can just select one and make a cat, and you see the iCalendar. So you can use any web dev client to browse such a server. That's pretty nice, and I can show you other servers. It's pretty easy. Let me check. For example, Scalable Ogo. I can just log into that. So it actually has address books. For example, you can go to contacts, and those are all my address books. For example. Anyway, that's just regular vcard files. Oops. Didn't copy. So it's just a vcard contained inside. So it's very useful for debugging. So, well, I'm actually almost done. Well, CalDAV, as I said, I would really like to get the open source client developers to support more of that, because I find it just ridiculous that they have very good Exchange connectors, but no connector for GroupDev or CalDAV, because it's so easy for them. They already have iCalendar and vCard, and they just need to implement, they even have the HTTP libraries for doing that. They just need to implement the proper requests. Well, I've printed some features for Open Connector, which is the open source Outlook integration. They need a lot of help. It's just one guy which is working on that. Well, and so if you have any questions, you can write me email, or the GroupDev list is a good one to ask questions. The CalDAV and CardDev list, and of course you can go to the website. So, questions?
I was very impressed with the fact that you worked on a protocol which is a smaller subset than the existing one. I think this is really nice. I'm sorry if you answered this in the first slide because I arrived a bit late, but does it handle collisions and groups and tentative of scheduling of events for...
Well, scheduling isn't part of GroupDev. That would be CalDAV scheduling, but it's usually done using IMAP anyway, so it's scheduling based on email. But groups are basically just regular folders. The server can choose anything. He can choose to provide any hierarchy he likes. And most servers I know also represent the groups and the group calendars as subfolders. And collision is perfectly detected. This is what HTTP e-tags are about, which allow optimistic locking. So there's no chance that writes collide. It's impossible.
But for example, is the collision handled on the client side?
No, the server does that. It's standard HTTP. That's done on the HTTP server.
Yeah, but the client has to give you a pop-up to say collision.
Well, yeah, of course the client needs to handle collisions. That's true. But the server actually checks whether there could be a collision.
The server checks for a file length with the same name, or does it...
No, it has something like an e-tag, which I explained before. I mean, time is a bit short to re-explain that, but it's perfectly working. There are no concurrency issues in that.
I want to implement the full CalDAV protocol on a server. Basically, I'm looking at implementing the RFC you mentioned. Where will I find a test suite to find that it actually worked?
There are also test suites for CalDAV. I know that. I never used them, but there's a test suite also at the Apple site, I think, which is written in Python. So there, I don't remember the name, but you can check on the CalDAV website. It has a lot of implementations and even the test suite, a link to that. So, sorry? Well, links to implementations. So, sorry, I can't follow you anymore.
I thought you said at the beginning of the talk that virtually no server implemented it, and I say there's lots of implementations.
Yeah, I thought you were asking for a test suite or something like that. Yeah, and there is a test suite, yeah, but not all servers implement everything in a test suite. So most servers just implement what is required for iCal.
So if I want a server to implement it, that's where I go. That's where I can go for that.
Yeah.
I keep calling to client developers. I'm a server developer.
Well, okay. Yeah, thank you. Or any more questions? No? Okay.